All right. Graph the following function and then find the specified limit. When necessary, state that the limit does not exist. So g of x equals to x when x is less than 0 and x squared when x is greater than 0. First, we must find the correct graph below, and then we must find the limit when x equals to 0. So when you graph x on your TI-83 or TI-84 calculator, it is going to go all across the x. Let's see. So if you go into your TI-84 or TI-83 calculator and you just type in x into the y equals, what you're going to see is that it's going to cross through the first quadrant in the top right and then the third quadrant in the bottom left. And what both of these quadrants have in common is that when the x is positive, so is the y. As for the x squared then turns into a parabola, and what happens is, let's say you do x is -1, then when you square -1, it becomes positive. So then when -1 is x, y becomes 1. And then if you square the 1 times 1 is 1, and y equals 1, and it creates some parabola shape. So now let's look at this graph right here. So when you look at this graph, this is the x part of the graph, and this is the x squared part of the graph. So with the x part of the graph, it's approaching 0 from the left. So that looks fine, right? And then for the x squared, it's approaching 0 from the right. So this looks like it'd be a good choice, right? Not quite. There's one problem with it. The problem is that with the x being either less than 0 or greater than 0, the one thing it's lacking here is an open circle. And so this would be the correct answer, because no matter if you choose x or x squared, it is not a greater than or equal to or less than or equal to for either of these equations. It's either x is less than 0 at x, and then x is greater than 0 at x squared. Therefore, there has to be an open circle here. With that in mind, what is the limit as x approaches 0? The answer is going to be 0, because when you plug in 0 into both equations, you get 0 out of that. And according to the graph in the first part, when x is 0, y is 0, and both of these points meet dead center in the middle, so therefore the limit is going to be 0. Okay. In a particular city, taxi cabs charge passengers $2.70 for entering a cab, then 40 cents for each 1/5 of a mile, or fraction thereof, traveled. If x represents the distance traveled in miles, then C of x is the cost of the taxi fare, where C of x equals to $2.70. If x equals 0, C of x is $3.10 if it's between 0 to 2.2, and so on. The graph of C is shown to us on the right. Use the graph to find each of the following limits if it exists. Okay. So first we have x is approaching 0.69 from the left. What is our C of x? So for our 0.69, it is between 0.6 and 0.8. And so if we look from the left here, you will see that the y is at $4.30. But what if we approach 0.69 from the right? Well, again, because we're in between 0.6 and 0.8 and we have a horizontal line, again, it's $4.30. For that reason, when we look at the last part, as x approaches 0.69, because it's $4.30 approaching the left and the right. Therefore, when we approach 0.69 exactly, it'll be again $4.30. The cost of sending a large envelope via first class mail is 72 cents for the first ounce and 17 cents for each additional ounce. If X represents the weight of a large envelope in ounces, then P of X is the cost of mailing it, where P of X is 72 cents if X is between 0 and 1 or less than equal to 1. P of X is equal to 89 cents if it's between 1 and 2, and so on through 13 ounces. The graph of P is shown to the right. Use the graph to find the following limits if it exists. So for this problem, we are looking at X approaching 2 from the left. So if we look at 2 from the left, so here's the 2, and if we approach it from the left, right here, you will see that the answer is going to be 0.89. It's not going to be 1.06 because at that point 2, that line stops right at 2. But here, this line stops at 2 right here. And if you go to the left, you see that our Y, or the postage cost, is 89 cents. But what if we were to approach 2 from the right? The answer would then be $1.06 because at 89 cents at 2, it stops right here. But if you go up, you will see that at 2, that line continues to go to the right. And our Y, our postage cost, is $1.06. And because of these differences in costs, if we approach from the left and the right, therefore at the bottom, the limit does not exist as our Y's do not match. The federal tax rate for the heads of households is given in the graph shown to the right. Use the graph to find the limit for 84.79 to the left, to the right, and head on. So for the 84.79 in terms of taxable income from the left, so if we go from the left side, you will see that tax rate is 10%. If we approach it from the right, you will see that the tax rate is approximately 15% because at the 84.79, at 15%, the point continues to go to the right, unlike at 10%. And because there is a mismatch, this means the limit does not exist. So now for number 18. This one is a little bit complicated, so what I'm going to do is in a bit I'm going to switch to GoodNotes on my iPad, share screen that, and you will see how to do this problem properly. So what we want is to find the value of C. So we have 1/5 x plus c when x is less than 5, and then negative x plus 9 when x is greater than 5. So what I'm going to do is stop share for now, and I'm going to share via my iPad through AirPlay. So give me a second to set that up. All right, give it a moment. All right, there we go. Okay, so how are we going to go about this? Well, what we're going to do is we are going to set these two equations equal to one another. And so our goal here is to isolate C. So what we're going to do is when x is equal to 5, we are going to plug in the 5 here and then the 5 there. So 5 times 1 over 5 equals 1 plus C. Then negative 5 plus 9, that equals 4. Then we're going to subtract 1 from each side to get the C by itself. Then 4 minus 1, that equals 3. Okay, now we got the last question for section 1-1. So this time our f of x is going to be equal to x squared minus 9 when x is less than negative 5, and negative x squared plus c when x is greater than negative 5. So again, just like the last problem, I'm going to stop share. All right, give it a minute. All right, so what we're going to do again, just like number 18, is we are going to set the equations equal to one another, plug in the x, which is negative 5, and keep going until c is all by itself. And that will give us the answer that we're looking for. So we'll do x squared minus 9 equals to negative x squared plus c. All right. Actually, let's do it the other way. All right. So we are going to plug in the negative 5 into x. So the negative 5 squared, that's going to be a positive 25. But when you multiply by a negative, that equals a negative 25. Then we have 5 squared, that's 25, and then minus 9. So then we're going to take the 25 minus the 9, which equals 16. Then we're going to add this 25 from the left, get rid of that, add it to the right side, and that is going to equal to 41. That is going to do it for section 1-1. I hope y'all enjoyed, and I will see y'all later.